Hello, everyone. Welcome to your computer architecture class for the summer of 2024. I will be your professor for this journey, and I'm really excited about teaching the class and spending a little bit of time with all you. So let's go ahead and get started. All right, so just a little bit of background on me. Well, so this course, of course, is required for a lot of you for if you are computer science majors or computer engineering majors. Um, a little bit of background about me. So I do have my doctorate in electrical engineering, and I graduated in 2022 from Rutgers University. My focus was actually on using neural networks to identify different components in the networking stack. So when we look at communications, you have um, your kind of forerunner things that you're looking at in terms of your applications, like your cell phones, your computers, your laptops, and all of that. So I ended up developing a lot of networks that were used to distinguish between different parts of that. Um, one of the things we looked at was modulation schemes, and we also observed the response of the networks to um, different websites and identify those websites based on just the header information only. So we didn't have any of the data packets, just the header information. And I was able to predict those websites with about 80% accuracy. Um, I currently work as a principal engineer for a company called Kierfot that works and designs navigation equipment. And then I teach part-time as a lecturer here at Rutgers. So kind of have the best of both worlds. A little bit of an interesting fact about me. I actually love to travel. I love seeing new places. I love just meeting new people and just seeing how people do different things in different countries. So my goal or what's on my bucket list is I actually want to visit every continent. So far, I toured with my jazz band in undergrad in Ghana, traveled to Ireland and Italy with a couple friends. So that covers Europe. Of course, I live in North America. So that covers North America. But I've also been to Canada several times. And um, I did for as part of my research, I ended up presenting at GlobeCom in Brazil, so that was pretty cool. So I have 4 continents down and 3 continents to go. Hoping to go to Japan next. So that's one of my goals. So the reason I'm doing that is because you'll notice that one of your first assignments as part of a recitation is actually for you to tell me a little bit of something interesting about yourself and identify yourself in 1 minute. So there you go. That's a little bit about me. Hope you guys feel like you got to know me a little bit better. Also, what's very important to me is my faith. So those are a couple facts about me. All right, so let's get started with the course information. So, if you've read the syllabus, you already know what we're gonna pretty much cover in this class. Um, this is an overview of kind of the 6 major areas that we're looking into. And we're gonna get into the von Neumann architecture today. We'll talk about that, and that'll also be part of your first recitation. Um, and you guys are actually going to explain and do a presentation on what the von Neumann architecture is, but I will talk about that in class today as well. We'll also do an introduction to C programming. Now, most of you probably already have some sort of programming background. We assume that as a part of this class, it's a prerequisite. You have programmed in some language, whether it be Python, Java, React, HTML, CSS, whatever the language may be, you have at least the programming experience to understand the basic concepts that we'll be talking about here. Now, we're actually going to spend most of this class, or this class is predominantly focused on C programming, and we'll talk a little bit about why we chose C instead of, for example, Python or I don't know, MATLAB or JavaScript. There's a specific reason that we're using C programming. We'll also talk about assembly language. What does that mean? What does that entail? And then we'll go into Boolean algebra and digital logic. Everybody's favorite topic, I'm sure. We'll talk a little bit about the memory hierarchy. So you notice that there's going to be a couple components in computer architecture that are extremely important, right? And this will be repeated. You'll notice that throughout the course, I will probably repeat things a couple times. If I do, you might want to listen because they'll likely be on the some of the exams. But the three things that you want to consider when you're looking at programming and when you're looking at computers are going to be your power, your processing, and also your memory. These are going to be vital components in developing a great system and also learning to effectively program so that you can get a very efficient program. And then we'll also talk about performance overall. How does your code perform? How fast is it? Is it wasteful in terms of energy? And how is it doing overall with whatever task it was you were assigned to? Now, I do want to take this time to emphasize this was stated in the syllabus, and we're going to say it again. Plagiarism is not tolerated at Rutgers, is not tolerated at this university. Do not plagiarize. So, what does that mean? It means write your own code. Again, write your own code. And finally, write your own code. That means that you don't say, hey, I can just plug this into Copilot or ChatGPT and it'll write the code for me. Write your own code. Do not fail this course because you think you can beat the system. Write your own code. You guys are extremely intelligent, you're extremely capable, or you wouldn't even be here. So don't waste time and fail the class because you try to have ChatGPT or Copilot or whatever other AI resource write the code. Now, it may look like, okay, maybe you can use ChatGPT kind of as a reference to learn how to do something, but spend time writing it yourself. If you need, to look online at Stack Overflow or whatever the case may be to find out how to do that, that's fine to use as a reference. But you should be the author of the code. You should be able to put that whatever the device is away and be able to recreate the code on your own without using this artificial intelligence. So write your own code. Don't fail the course. If you do plagiarize or are discovered as using AI to generate your entire code or assignment, that will result in it being reported to the academic office. And that's going to have really bad consequences for you. So just don't do it. Just avoid it. Just avoid it. I mean, you don't want to waste thousands of dollars because you decided that you were just going to try to beat the system. Just avoid it and just write your own code. I promise you, it'll make you a better coder. In addition to that, don't copy your work from others. If your friend is like, oh, I already took that class, I already have this program, just go ahead and use it because we have ways to identify those particular items and those particular codes that were written previously, and also anything that was generated with AI. So we'll be able to detect that and then you will be held responsible for anything that you've copied from others. As I stated before, incidents, they will be reported. They'll be notified. The academic office will be notified. I'm not sure if this results in being expelled or kicked out of school, but it will definitely be costly for you. So just write your own code. And in addition to that, your grade will be severely impacted, which means you could basically fail the course for trying to get ahead. So if you do have questions or need help, I'm available during my office hours to kind of help out with some of the coding, with any questions that you might have, and I also will be available via email. But again, write your own code. Don't cheat off of your friends. Don't use other people's code. Just write it out. Now, of course, everybody is going to be extremely concerned and interested in what the grading distribution is. You'll see this here, and it's also in the syllabus, which we're going to take a look at in a few moments. So the class is really broken up into three types of assignments. programming assignments, which are abbreviated PA. So your programming assignments are going to be 45% of the course. So assignments 1, 2, and 3 are 15% each. And then your recitations are going to be 15% of the course. Now, recitations are a way for us to really assess whether or not you have grasped the concepts from the course. And the best way to do that, because we're in kind of like this digital age, and you can basically look a lot of things up. One of the things we can kind of enforce that you have learned this is by having you explain yourself. One of the best ways to learn a concept and to learn something new is to teach somebody else. If you teach somebody else, that means that you will have to understand it a little bit better. So, recitations are just an opportunity for you to verbally express or verbally explain some concept from the class. Now, some of them might be terms, some of them might be some programming assignments and just explaining the way that you presented that or whatever the case may be. Now, this is 15% of the course. So if you do not do these recitations, that means there's no way you can get an A. So just keep that in mind. And the recitations are relatively short. They will be 3 minutes or less, with you just talking about a topic. Some of them will require slides, but all of them will be using a video. So you will have to be on video, on camera, explaining this particular item. And that's because, I just want to see your lovely, beautiful faces. No, really to get to know you better and to make sure that you're not using some sort of robot or something to design these recitations, right? So really explaining some of those concepts from the course. And the last section is really tests. So that includes both quizzes and exams. Now, all the quizzes and the exams will be posted on Canvas. Canvas will be our platform both for grading. Canvas is also the main thing that I will use for communication. And these will be timed exams that will be available on Canvas. I'll go over a little bit of the kind of the due dates of everything. But your quizzes themselves are 10% of your grade. And then your midterm and final combined is 30%. So that makes up 40% of your grade. All right. So just that breakdown again. You got your programming assignments as 45% of the course. So that's almost half the course. The recitations are going to be 15% of the course. And then your quizzes and the tests, quizzes and the exams are about are 40% of the course. So it's kind of like that's the distribution that we're using for this particular class. So as I stated before, my preferred way of interacting with you guys will be on Canvas. That means you can inbox me on Canvas. I will also post discussion boards where you can ask general questions about the class. Because I get a lot of emails and because I don't want to miss what you guys are asking, it would be best I'm going to have you all just communicate with me through Canvas, and then I can respond to them in a more rapid or appropriate time than if you just send me an email to my main email address. Now, the discussion boards will be available each week for those who have general questions about the class. Or general questions about the topic. So the topic might be, hey, what's due this week for class? Now you could also just look in Canvas, but or the question might be, well, what is the difference between the von Neumann architecture and the Harvard architecture, right? That could be something that maybe is posted in this discussion forum, rather than just emailing me or messaging me individually, because that will allow your classmates also to get the response to that question as well. Now, all of the lectures will be posted. The lecture slides will be posted on Canvas. So you will have access and they will be available to you prior to the week or, prior to the time of lecture. So there will be sets of lecture that will cover about 3 hours, 3 times a week for this class. Unless there's an exam, in which case there may be fewer lectures, excuse me. Now the lecture video links will also be posted on Canvas. It's just easier for me to post the links to the video rather than the full video on Canvas because of space. But you'll be able to access those and get to that information. So what I'm going to do now is we're going to take a little bit of time and just look at Canvas. Um, and I want to walk through that with you just so you have an idea of how the things are structured. So by now you should already know how to access Canvas and get into the actual class. So right now, here's where I am. If we go to this actual course, you'll see, okay, I'm in this computer architecture class here. First thing we're going to look at is if you go on this side view here, you'll have this course syllabus with the main information from the class, right? Here's all my contact information. Now, as I stated, my preferred method of contact is Canvas. But if for some reason you cannot reach me through that, you can email me. I will just make a note that it may take me longer to respond to that email if you email me from my on the personal account. Our teaching assistant is Alvarez Delvani. He has a lot of experience in this class and is very knowledgeable. So if you have questions, you feel free to reach out to him or myself regarding the class. Here are your textbooks. Books, you guys can go ahead and read that. Academic honesty policy, don't cheat, don't plagiarize. Go ahead and read through all that. Rutgers is built on making sure that they include a very diverse community. So if you have issues with or you feel like you've been targeted or something, feel free to report that and include that information. Health and safety, make sure you guys stay healthy, blah, blah. We went over that. What I really want to look at here is the courseworks and the dates. Now, I try to keep things pretty consistent in terms of just getting into a rhythm. So typically, what you'll see is that there'll be 2 assignments due each week. Now, those assignments could either be a programming assignment and a quiz, or a recitation, depending on what that week is. But there will always be 2. And except for the first week, your assignments are going to be on Tuesdays and on Saturdays, right? So your quizzes, your exams, the tests will be on Tuesdays. So just make time in your schedule. The exams will be available for 24 hours. So from 11:59 the day before, 11:59 p.m. the day before to 11:59 p.m. the day of, you will have access to the exam. So now that you know that it's Tuesdays, do whatever you need to do to arrange your life so that you are able to take the exam within that time frame. And then on Saturdays, those will be when the programming assignments are due. Now, the reason I made them on Saturdays because I did get some messages from students who either work or they have internships in the summer, so they're working or they're doing other things while they're taking the class. So I figured it would be easier if they had the opportunity if there was opportunity to finish it on Saturday. If you don't like the fact that they are due on Saturday, get your assignment done earlier, right? You have the option to do it anytime you want. They will be available to you. So if you want to get them done before Saturday, feel free. And then week 1 will be the only week where you will have something due on Thursday. And the reason for that is because I didn't want you guys to come in the first day of class and then have an assignment due that Tuesday. So you'll see that recitation 1 is due on Thursday, but every other week you'll have a quiz or an exam on Tuesdays, and then whatever assignment is associated with that week will be due on Fridays. All right, we already went through the recitations and the extra credits. The extra credits will be available at my discretion, and they will be added to your grade if you should decide to do them. All right, so that's your Canvas walkthrough. While we're in here, you might as well take a look at the first assignment. All right. So remember, I was saying the first assignment is this recitation assignment here. So if you go under assignments, you'll see kind of where those assignments are. Now you're only going to be able to see what is available at that particular time. So there will be a time frame where we start the availability of the assignments. Recitation 1, the first part of it is a personal reflection. So you'll see it's due, but you won't be able to see the details until it's actually available. Now, recitation assignment, I will tell you that this is basically the first one is a personal reflection. It's just a 1-minute video where you're telling me a little bit about yourself. Recitation 1, the concept demonstration is you demonstrating that von Neumann architecture. All right, so there you go about that. So let's go ahead and get back to our slides. Where are the slides? There we go. All right. So, all right. So we went through that. This is not the way I want to do it. All right. So, all right. So now let's get a little bit into kind of what we're talking about in the class, right? So, why computer architecture, and what the heck does that have to do with programming, right? Why do I need to learn computer architecture if I want to be a data analyst or a data scientist? So we'll talk a little bit about that. We're going to talk about the current architectures that are available, some of the components and systems, and from a programming perspective, how do the programs currently run on these devices? And all this is going to be important because it will help you code a better program. We want to talk a little bit about the hardware concepts throughout the course, how you design and build better components. And we also want to go into how do you design and build systems from these components. So we'll talk a little bit about that. And really, the bridge that we're going to bring in is, how does programming relate to computer architecture, right? What is the impact on that particular thing, right? How does computer architecture impact high-level languages? How can I make my program faster? How can I make my program more efficient? And how do I really make it run on longer battery, right? Remember the 3 things that I discussed as those important concepts to programming, right? They were your processing, your power, and then also your memory, right? So all of these things you're going to consider as we make these discussions in class, right? So with that, let's talk about how we conceptualize and represent computers overall, right? Um, when we think about anything or a lot of things, especially if it's high level or it can be very complicated, one of the best ways to look at that or to understand it is to develop an abstract model, right? If I'm talking about Ohm's law, or if I'm talking about something in algebra or some complex system, why not develop this model to help me understand it better, so that I can break it up into components and really get a good grasp on whatever I'm doing, right? So when we look at that, one of the things that helps us to understand computers and how they work is the ISA, right? Now, this helps us model basically how this software controls the central processing unit. So let me back up a little bit. So we talked about computers, computer architecture. As we all know, or most of us know, you're going to have a central processing unit that basically controls a lot of the stuff within the computer, right? So the ISA is going to allow you this instruction set for how you are going talk to your computer. It also sets the instructions for the software to interface with the hardware. Um, Now, keep in mind, one of the things in this class is we're really doing a bridge between the hardware and the software, right? So your ISA provides these instruction sets between those two. And finally, it really allows this user level interface to tell the hardware what to do, right? So you can think of the ISA, if we use a restaurant analogy, your ISA is kind of like your menu, right? Your menu is going to tell the user, right? The user here, what you can actually use, how you can communicate with the kitchen, right? It'll tell you what's available, and then for the kitchen, it's gonna give them instructions for what they're gonna prepare you, and it will also tell them what the ingredients are, right? So we can really consider this ISA structure or this ISA architecture as kind of a overall menu for our computer architecture system. Now, okay, and I'm sorry, taking a step back a little bit. For ISA stands for Instruction Set Architecture, right? So instruction set architecture, this hierarchy of how we're modeling different things and allowing the hardware and software to interface. Now, as I was stating before, that it's gonna give you a lot of it's gonna define a few things, right? The data types, the registers, the hardware memory management, and what you're gonna do in virtual memory. Now, all of these things are going to be important in terms of how the computer system actually interacts. All right. Now, another thing you want to talk about, right? So you have we're on in this restaurant system, right? We have our menu, right? The ISA serves as our menu. It's this thing that I can look at and say, hey, I want a double bacon cheeseburger with some curly fries on the side, and I want a Pepsi. Actually, I want a cherry Coke, right? You can order that on your menu as your user, right? And then the menu also allows the kitchen and the chefs to know what you want and what the ingredients that requires. And then we have this other thing that helps people interface, right? Besides this besides having this user level interface that tells the hardware what to do, we also have something that is the actual program that you can see, your GUIs that you literally see, right? And a lot of times it's called, or we think of that as an API, right? We hear that term a lot. And that stands for Application Programming Interface, right? And your API does a few things. It allows users to access information. It also lets you let the applications themselves communicate with one another, right? Anytime we're trying to pull information, a lot of the databases that we have today, they might be from the AWS using, Amazon's database system, right? So how do I get that information, right? When I want to get something from the Google server, how do I get that? The API allows you to access that information, and it lets your computer communicate over the web to the servers at Google or Amazon to get your information, right? So it has the database app. The API allows the database application and your web browser to really communicate. In addition to that, it also transfers information between applications, data, and devices, right? So it's kind of provides this handshake between what you want to do, right? So I might say, hey, I want to pull off I want to be able to get from Rutgers, I want to be able to download the slides for this presentation, right? Then you're telling it what you want to do from from the Canvas site, and the API is going to go and pull that information down from whatever database it's stored in, and then help you to access that from your particular computer. So Whereas we thought of the ISA as kind of the menu for the restaurant, your API is a little bit more outgoing, right? It can be used inside and outside of the actual computer. We can think of that as the Grubhub for the system. And here's the reason I want to make that analogy. For your API, because it's this interface and this communication between the two applications, it's allowed to go outside the box of just your computer, I'll say. It takes in these requests. It also tells the system the desired task and it returns a response. That reminds me of Grubhub, right? If I say, hey, I don't feel like going out tonight, I want to order something from Buffalo Wild Wings. I take out my phone, right? Pull up the Grubhub, DoorDash, Instacart, not Instacart for ordering food, but Grubhub and DoorDash application. I look at the restaurant's menu and what they have. I put my request in. That the Grubhub serves as that intermediary where you can say, okay, this is what you want, right? It takes your request for what you want, and then it tells the restaurant what your order is, and then it also returns your response. The API does the same thing for our computer system, right? It's this bridge and this communicator between you, the user, or the program, and the other program or device that it's interacting with. So now we have our, sorry about that. Now we have our ISA, right, which is your menu. You have your API, which is kind of like your Grubhub, and you're using all of these to accomplish a particular task. All right, so we have API, right? And now let's just, because we want to make things a little bit more complicated, we have something called an ABI, all right? API is your application programming interface, right? Application programming interface, and your ABI is your application binary interface. Now, you can consider the ABI is the API for the CPU. Say that 5 times really fast. The ABI is the API for the CPU. What does that mean? So the ABI, as it indicates, is using binary code, right? And if you know anything about what, we'll talk a little bit about this in class, your CPU, when you're giving it instructions, it takes those instructions in binary language. It's not going to take, if you say, hey, I want to turn off my computer, if you tell it that verbally, it's not going to get that. It has to receive it in this binary interface. So that's what your ABI allows it to do. It's this messenger that takes the information, the instructions that it receives, and translates it into this machine code that can be understood by your CPU. It also, this ABI includes both the operating system and the hardware platform itself, because it needs to provide this communication between the hardware and the actual operating system that is compiled, that it's using. It also, it's really a compiled machine language version of the API, right? So recap, your ISA is going to be your menu. It's going to provide instructions for how you're going to do all this stuff. Your API is this interface with the outside world. It's like your Grubhub between you or your application and the other application. Your ABI is kind of like a lower interface between your hardware, the operating system, and the CPU, right? It's this API directly to the CPU, where it's like an interpreter, it's a translator that's translating the information that it got from the hardware down on into a language that the CPU can actually understand.